Hi everyone, this is Adam Green here from ATA Engineering. It's just after 1. We'll get started now on our webinar talking about what's new in STAR-CCM Plus. And today we're going to look at a subset of some of the new features. And today I'm going to just kind of say hello to everyone, and then Chris Ostoich, one of our engineers at ATA, is going to take over with a deeper dive in some of the features. So with that in mind, let's quickly introduce ATA. Actually, let's introduce the introduction first. So, we're really going to look at 3 parts of the new STAR-CCM Plus side of things. The search tool in 3D CAD, the generalized cylinder mesher, and also the latest revision of the CAD client connecting to NX 1847, which is probably one of the most exciting parts of this. And so I think most people online know who ATA are, but I thought I'd just give a few slides on we're an engineering consulting group based in San Diego, Huntsville, Denver, and Washington D.C. We have a very highly talented bunch of people from many PhDs, many masters in engineering that really do a lot of different aspects, and we have around 8 people specializing in STAR-CCM Plus, and Chris is one of the lead guys in that team. And so a lot of people haven't heard of ATA, but really we have a long lineage going back to SDRC, where we used to be a services group of SDRC out of Cincinnati, but at that time they had a services group in San Diego that in 2000 split away from SDRC and became ATA Engineering. So we have a long legacy in Unigraphics, NX, and pretty much everything after that. So we are kind of the world's experts in those tools, especially NX, CMAP, and so forth. We're also a Siemens Platinum partner selling mostly Simcenter tools, and especially STAR-CCM Plus HEEDS, as well as NX, Simcenter 3D, all of the tools under that portfolio. So not only do we sell all of those as part of our partnership with Siemens, but we also do full support. We've just started doing training for all of those. And so really we're a full service center for all of Siemens products under the Simcenter portfolio. And so most of the people on the line, and really what I want to make sure too is that we've only got a few here today, so it'd be great if it could be interactive. So certainly if you've got questions, please unmute yourself and really talk to us today, so that if you've got questions on Chris's presentation, we can really talk about those now live while we're here. But really, as you all know, STAR-CCM Plus has a huge diverse set of functionality that can be applied to various aspects of the physics in the world. And here's just a kind of sampling of those things, just to really highlight how flexible it can be. And so when you look at the new things that were added in STAR-CCM Plus 2019.3 with the new naming convention this year, it's a lot easier to kind of follow it. .3 is obviously the third release. In our original invite for this, we did talk about doing a presentation of Simcenter Nastran co-simulation, but it turned out that wasn't quite ready for prime time from the Siemens perspective. So we had to basically cancel that from today's presentation, but we'll certainly revisit that later. So the pieces that Chris is going to focus on now are these 3 parts of the new release. And now there might be other things in there that people are interested in. And certainly, if you are, then call us and we can talk about those in more detail. But today, Chris is going to dive into more detail and really show you some examples of these 3 things. So the search tool in 3D CAD to really make it easier to bring in very complex geometries and filter out the things that you really don't need. Secondly, the generalized cylinder mesher has really got some new things that make it really much more productive. And then lastly, the connection to NX 1847. He's going to show you some history of some previous work that we did using an old methodology and now the new system for using the CAD client. So with that, I am going to stop sharing and ask Chris to take up his side of things. And over to you, Chris.
So again, my name is Chris Ostoich. I'm a project engineer here at ATA and a user of STAR-CCM Plus. I'm going to start with describing the generalized cylinder mesher. So this is used with the polyhedral volume mesher to generate an extruded mesh along these generalized cylinders. So what that is just a bounding wall with a closed loop at each end. And it's very useful because although the user can flag certain geometries and force the generalized cylinder mesher to operate on those geometries, it does a good job at automatically detecting suitable geometries without the user having to do anything. The cells are then extruded along the axis of the cylinder, and these extruded prismatic cells generally reduce the overall cell count and can, in some cases, improve the solver convergence rate. So I've got an example here on the next slide. Which is just one of these kind of straws. So this is probably pretty irrelevant to any of the applications that anybody on the phone is interested in, but it does a good job at demonstrating what this generalized cylinder mesher does, which is follow a cylindrical geometry that might have a lot of complicated turns. So here we've just got this straw, and here are the boundary conditions for the simulated results here. And it's got just a few turns here. And on the left, I show a picture of a portion of the straw that's just meshed with the polyhedral mesh, and it results in a little over 100,000 cells. And then on the right, by just flipping the generalized cylinder mesher switch, I get a mesh over that same geometry with about 40% fewer cells. So showing the results here, the results between the generalized cylinder meshed straw and the polyhedral mesh straw were similar, but given that the generalized cylinder mesh had 40% fewer cells, it ran much faster. And then when we look at the residuals, this is just a norm over all the residuals. You can see I started from the same initial condition for both cases, and the generalized cylinder mesh converged at a much faster rate. So I'm going to switch over to STAR-CCM Plus here and just show you kind of how easy this is accomplished here. So this is a bit different than the geometry I showed you. Here I've got the straw and it's kind of going into a container. And I just wanted to show you how well the mesher did at identifying the generalized cylinders that could be meshed, and then how it transitions to a polyhedral mesh in a region where the generalized cylinder mesher is not appropriate. So all you do to activate it is select generalized cylinder mesher there, added to the tree. I'm going to execute. It's going to quickly generate the mesh. It just takes a few seconds. This mesh initially was a little over 140,000 cells. And you can see here that it identified the cylindrical geometry that could benefit from these prismatic cells along the straw portion, and then it transitions to a normal polyhedral mesh in this larger kind of region. So that's how easy it is to do this, and you can really get a lot of savings both in meshing time and then computational efficiency. So are there any questions regarding that feature?
And I have the meeting settings such that you can unmute yourself either by hovering over your name in the participant list and clicking unmute, or not in the screen share window, but back in the main meeting window. Down in the bottom left, there's also an unmute button there.
Looks like we've got a question in the chat window. what settings did you use for the generalized cylinder?
So I didn't have to activate any additional settings other than checking that I wanted to use that mesher, which would automatically detect the cylinder. The way that it does that is it looks for, again, a kind of closed cylindrical geometry. It doesn't have to be a cylinder, and this is something that I didn't point out earlier when I was talking. It doesn't have to be strictly a cylinder. It can just be a bounding wall with a closed loop at each end. So in this case on the right here, it's actually a square cross section. It does have the requirement that it can't have sharp corners. They have to be rounded. And in this case, it's a cylinder, but it's got a hole going through it. So other than that, I didn't set any settings. I just created a cylinder that satisfied those requirements.
Chris, this is Adam. Can you show us the mesh on the live version and zoom in onto the end of that pipe that you've got running?
Yeah. So is this what you were talking about?
Yeah, but I meant in that. Can you do a side view of it so we can see the end of the pipe in more detail?
Yeah. Let me pull up mesh scene here. And so one of the things that you might be asking yourself is, hey, we've got a cylinder here. Why isn't it applied to this portion? And there is, for the automatic detection, it does look for a certain aspect ratio of length versus diameter.
So Chris, we have another question in the chat from Herson, who says, is this different than directed meshing?
Yes, it's different from directed meshing, and I think that the big benefit here is the ease of implementation. It was the click of one button for it to say, okay, I'm going to identify where I want to kind of apply this directed mesh, and I'm going to identify where this is appropriate and apply it without the user having to make any additional changes or flag any additional boundaries.
So it's the convenience and speed enhancement mainly.
Yeah.
Excellent. Thank you. Herson, does that answer your question?
Great. All right.
Great.
Okay. All right. The second thing that I want to talk about here is the search tool in 3D CAD. So this is just a feature enhancement for the STAR's native 3D CAD tool, and it just helps you to find and organize geometric entities using search criteria that can be based on geometry features or even similarities between existing features on the CAD. It can also be it can also be used to help detect clashes between features. I'm going to demonstrate how you can use it to find parts or features on a part that are similar. So the similarity is based on the surface area of a feature, the volume, the perimeter, geometric features like that are automatically detected when you flag a certain feature. And so this can significantly aid a CFD analyst in geometry preparation when they're given some dirty CAD that needs to be cleaned up. The example here that I'm going to give is, I don't know if anybody has seen the movie The Aviator, but it's about Howard Hughes, and part of it is his ambition to build the fastest airplane. And so this is a reflection of Leonardo DiCaprio looking at this plane and just running his hands along the rivets, saying he wanted those rivets gone. He wanted the body of the plane to be smooth. So very much like Leonardo DiCaprio, a CFD analyst might want to identify all of these rivets and remove them from some CAD so that they could build a nice mesh to run their model on. So here is my example. Again, it's a very simple example. We've got this bar with a bunch of these little rivets on it. And I, as a CFD analyst, want to get rid of these rivets. So I've got two options. I can either control click 144 of these things or use the new search tool in 2019.3 to just find similar features. That'll be on my next demo here. Switch over. So this is the geometry scene of that part. And I'm going to go into 3D CAD. So this part was imported as a parasolid into 3D CAD. And as I said before, I can go through and select all of these and remove them that way. And it wouldn't be too bad, actually, in this case, since I know where all of them are. But it's unlikely that an analyst is going to want to look at a part like this. The part will most likely be more complicated, and he'll really have to search for these features that he wants to remove. So instead, I'm going to opt to use the search tool. So what I do is open this design filter up here. My search criteria, you can set up conditions based on feature length and size. I instead want to say find similar. And so it then says, or then indicates that it wants me to select a feature on the geometry. So I just select one of these rivets here. And then I say search. And it quickly finds all 144 of them. I can then direct those into a filter to be used later, or just say I want those to be selected after I close this search tool. I say selection, press OK. Now all of those are selected. I can just right click on one and say delete. Confirm. And now when I exit out of 3D CAD, update my geometry part to reflect the changes in 3D CAD, all of them are gone. And I can now proceed with creating my mesh and not having to worry about resolving all of those little features. So are there any questions regarding that?
Chris, this is Adam. That search box, is that totally new or is it enhanced? Is that a totally new feature in this version?
It's a new feature.
Okay.
As far as I know, it's a new feature. I should look. Definitely the find similar and the clash and the clash detection are new.
So Herson has asked, does the surface repair tool have similar function?
I don't think it does. I think this is just in 3D CAD. So what you would want to do is bring in whatever your geometry is into 3D CAD so that you can operate on it there instead of going to File, Import, Surface Mesh. You want to go to New 3D CAD and then from here go to Import CAD Model.
So there is a workflow to get you into repair.
Yeah.
To utilize this. Okay.
I think it's a pretty powerful functionality. So maybe in a later release, it will be available in surface repair. But well, I'll look at that later.
Okay, so Herson is good with that.
Okay, great. Okay, so the final thing I want to talk about is the CAD client. Was there a question there? Sorry.
And no, you're good.
Okay, I thought I heard something come through. My bad. Recently, support for NX 1847 has been implemented. So this CAD client enables complicated geometries to be parameterized and modified within STAR-CCM+. I'll talk about this geometry on the right a little later, but as you can see, it's pretty complicated. And if you wanted to look at several variants of it, it might be a pain going back and forth between NX or your chosen CAD tool. I want to mention that this is also supported for Creo and CATIA, but NX is the preferred CAD client here. And so I'll be, again, talking about this geometry a little bit later. So the CAD client, in combination with STAR-CCM+, enables efficiency gains. So within STAR-CCM+, the powerful mesh operation pipeline makes design changes easily automated. Large parameter studies can be automatically accomplished with the design manager, which comes standard with STAR-CCM+. And then with the additional STAR-CCM+ Innovate license, automated design optimization on some complicated design like this is made possible. So the example that I'm sharing today is actually a technology developed by ATA Engineering called the engine air brake. And so what this does is it's a nozzle that goes on a jet engine, which uses this deployable swirl vane mechanism to create swirl in the exhaust plume, converting engine exhaust from thrust production to drag production, or actually thrust reduction. What this does is it allows or enables slower, steeper, and therefore quieter flight on landing approach to satisfy local requirements in different at different airports. So this was a large effort, and it was analysis driven, meaning that the analysis methods that we used, CFD in STAR-CCM+, informed the design. So this meant that there were numerous manual CFD and CAD iterations. To develop this design here, which is the prototype design, took 150 CAD models and CFD simulations to arrive at. So that equates in several hundred engineering hours in model preparation, mesh, and simulation. Because how this was being done is in NX, the geometry would be tweaked or some parameter would be changed. The parasolid would be exported, imported into STAR. All the preparation steps would be done in STAR-CCM+. Simulation would be run, and that's one of these 150 iterations. So using the CAD client, this is made much more easy. The example I'm going to use is just the swirl vane angle here. So pretty much the workflow is within NX, we've got this STAR-CCM+ kind of tab here, and you just click this design data, and it allows the user to select whatever parameters the user wants to make visible to STAR-CCM+. So I just select angle here, and then that's exported, and those parameter changes, those parameters are made visible in STAR-CCM+, and changes can be made within STAR-CCM+, which then start up an NX instance in batch mode to update the CAD in STAR-CCM+. So it removes a lot of the manual steps that an analyst would have to do or a designer would have to do to get the model between the two softwares. So here's a video showing just 4 iterations of that, and this is done automatically. You can see here that the swirl vanes are being modified in NX, which are then passed back into the STAR mesh pipeline. STAR meshes it, runs the simulation, and what I'm showing here are the streamlines and how the streamlines are affected by the change in the swirl vanes. So I'm just going to show an example of how easily this is done. Here I've got my engine air brake geometry. The swirl vanes are in the stowed configuration. I go over here to geometry. The CAD Client Model node is enabled, and you can see we've got this the part here with the 2 arrows, meaning that there's communication between STAR-CCM and NX. And then I can just highlight this parameter, change it from 45 degrees, which corresponds to the stowed condition, and maybe go to 5 degrees, which is close to fully deployed. And update the model. And this takes a second to launch NX in batch mode and make the change, and then communicate that change back to STAR-CCM Plus. But it's much faster than going into NX, making the change, exporting the parasolid, bringing it back in STAR-CCM Plus.
Hey, Chris, this is Adam. Just a note there that you could have had NX kind of alive and running at the same time, and then it would have done a direct transfer in memory, right?
Well, you'd have to, in my playing around with it, you have to kind of make the change in NX, save it, and then open that in STAR-CCM Plus. But I might be wrong about that.
Okay.
But anyway, here is the new geometry with this change, and so this is just one parameter that I'm changing. But you can imagine that a number of these parameters that governs the behavior of this complicated kind of geometry and mechanism can be set up so that you can really streamline the process. Okay, and so here's a little video of actually what the prototype looked like during testing. So this analysis-driven design process utilizing NX and STAR-CCM allowed us to produce a successful engineer brake prototype design. And through this, the technology was matured to a TRL of 6 with the demonstration of the fully functional prototype shown in that video there. You can see that with STAR, we were able to match well the experimental data that we took, and also design a high-performing engine air brake. However, hundreds of manual engineering hours could have been saved at different stages where using the CAD client could have kind of streamlined a lot of manual labor that the designer had to go through. And then looking forward, so this is the stage where we're at. We've demonstrated a fully functional prototype, but if we were to start building these and trying to optimize them, we could use Design Manager and the Innovate license to actually do optimization using a robust high-performance proprietary algorithm which would drive these parameters towards an optimally performing engine air brake. So are there any questions regarding that?
Chris, one thing I wanted to mention to the audience, one of the key things here is that if you adopt this process where you use the CAD client, and let's say you run a design manager sweep of models within STAR, at the end of that, all of those can be represented as geometries in NX in this case. And that means that if you're doing a parameter sweep or you're doing an optimization within STAR's Innovate, at the end of it all, you have your CAD ready to go and make, something either with 3D printing or however you make something. And so that bi-directional nature of going from the CAD to the analysis tool and back again going to really save you a lot of time. So you can do an analysis study in STAR, and at the end of it, you've got geometry, ready to use, however you need to. And obviously, NX is owned by Siemens, as we all know, and so the interface to NX is a little more sophisticated. But this technology and the CAD clients exist for both PTC, Creo, and CATIA. So if you're not using NX, you're using other things, this can still be done with those tools. And so anyone who's on the line should think about trying it out if you're using STAR already. And if you wanted to, we can certainly set up trials for you. Thank you, Chris.
Thanks, Adam. You want me to pass the share back over?
Well, yeah, I think we can leave it there, really. I really wanted to say to everyone, has anyone got any questions on the line that about any of those topics we've discussed? And also, actually, yeah, do send the share back to me, because I wanted to bring up the our list of things that we can talk about. And really, is anyone on the line interested in any of these other things? Is anyone interested, especially in co-simulating with Nastran? That's quite a new thing. And as I said earlier, we had some problems with that, but we certainly hope to get those fixed very quickly. So if anyone's interested, we could certainly show at a later date some STAR-CCM Plus coupled to Nastran. So if anyone can either put in the chat or speak about any of these things they would like to see in this list here, let us know now. So yeah, here's the 3 things we talked about today. Anyone interested in anything particular aside from those 3 in this list? All right, well, basically, we'll put this recording up on YouTube, and so anyone who's got some comments after today, let us know. Hurston's mentioned he'd like to see Monte Carlo radiation option. I mean, that's quite a new thing, and I know Chris is actually working on some projects which may involve that. So certainly at a future date, we could come back and do another webinar on that. All right, thank you, everyone. We'll wrap up for today. We appreciate your time joining us for this lunchtime snippet, and we'll see you soon. Thanks a lot. Bye-bye.